Hello, in today's video we're going to be talking about molarity and the dilution equation. So first off we have to understand what the definition of molarity is. And molarity is just a defined unit. So if we wanted to know what molarity is equal to the very specific units, moles of solute. Solute is the thing being dissolved per 1 liter of solution. So this is my shorthand notation for solution. So it is moles of the solute, the thing that's being dissolved, divided by 1 liter of the total solution, not the water that's being the dissolving agent, but the solution itself. So let's take a look at what this would look like. Let's say we have a beaker, and inside of it we have 4.0 moles of sulfuric acid, H2SO4. This is a solid powder. Now what we can do in a laboratory is we can take the solid powder and we can pour in a certain amount of water. So let's say we pour in enough water such that the total solution goes up to 2.0 liters. So now the solute, the thing that was in the bottom, that was the solid, which was the sulfuric acid, has now been dissolved, and it's been dissolved in enough water such that the total volume of the solution is up to 2 liters. Well, now we can easily find out what the molarity of the solution is. Molarity is equal to the moles of solute. This was the solute, 4.0 moles of H2SO4, divided by the total volume of the solution. The total volume of the solution was 2.0 liters of solution. We plug that into a calculator, or we can do this one in our head. 4 divided by 2 is just 2, so we get 2.0 capital M. The way to write molarity is with a capital M, and what we'll call this is 2.0 molar. So that capital M represents molarity. It also represents the word molar. So 2.0 molar H2SO4. Now, really, these two are identical and equal to each other. So this capital M can be replaced by moles of the solute per liter of solution, or we could just write out the capital M. So this is our understanding of what molarity is. This definition is going to come in handy when we start figuring out what molarities are tomorrow of a lot of different solutions. Now I want to do something else with this solution. So let's say we had our beaker. We know that it's filled with 2.0 molar H2SO4. And we're going to say that we have the 2 liters here. We can also do something where instead of just taking the original solution and finding the molarity, we can add in more solvent, which is the water in this case. So if we added in another amount of fluid, another 2 liters of water, such that the total volume of this solution is now 4 liters. So think of this as a bigger beaker, and now we're up to the top part, and now we have 4.0 liters of solution. Now we can set up an equation where we can calculate what the molarity is of this new solution. So we have the initial volume of the initial concentration, and we have the secondary volume. We've added in more solvent, but we don't know what the molarity is. How in the world are we going to solve for this molarity? We have a very simple equation. Now I'm telling you an equation is called the dilution equation. It is written out as M1, the first initial concentration, times the first initial volume is equal to M2V2. Secondary concentration times secondary volume. This equation can only be used for the dilution problems. It cannot be used for acid-base chemistry, which we will get to on Monday. So let's see what we can do here. We have the initial concentration, we have the initial molarity, and we have the secondary volume. So now we can solve for M2. M2 is just M1V1 over V2. We have all 3 of these variables. M1 was 2.0 molar. V1 was 2.0 liters, and V2 was 4.0 liters. So now M2, the second concentration, is now 1.0 molar H2SO4. So all we've done is we've added in more volume here, more solvent. We've decreased the concentration of the second of the new solution. So it's the same thing as if you had Kool-Aid. If you keep adding water to the Kool-Aid, if it was a red Kool-Aid, it was really dark at first, but you add more water, it keeps getting lighter and lighter and lighter. That's because the concentration of the Kool-Aid is actually going down. So these two types of problems, calculating the molarity, which we can do by moles of solute per liter of solution, and calculating a secondary concentration or a secondary volume given initial and final starting points, we can use the dilution equation to calculate that secondary concentration or secondary volume. So we'll be doing a lot of these types of problems tomorrow in class. With that, I want to say have a good night. I will see you all tomorrow.